Hi, I am Praneetha Singh from the Hills Grammar School. I would like to thank the Question 11 marking team for their professionalism, dedication, and perseverance, especially marking well into Term 4. I would like to also thank our supervisor of marking, John Dillon, and Warren Black, who helped the extension markers with their ongoing support during the marking period. So let's get started in terms of the summary. So the summary, the team felt the question was accessible to most students, especially being question 11. Most students attempted all of this question. This question was 16 marks and had a variety of questions from the different topics. So the overall general comments, being question 11 and relatively straightforward, most students answered this question quite well. Students need to be aware of mark allocation, especially 3-mark questions, and provide sufficient working to warrant them being awarded the marks. Carelessness, especially in terms of powers, the use of their powers was very common. Students need to use the given reference sheet more cautiously, especially when considering integration of trigonometry. So the first part, where they had to simply add the two values. Very well done. Very few errors, but most students obtained their 1 mark. With the expansion and simplification, there was 2 main ways students answered this. Many was very successfully used Pascal's triangle to find the coefficients with the correct signs. Or the second way, many used the 2a minus b squared times 2a minus b squared. So they expanded 2 binomials and got the correct expression. The common errors here were ignoring the negative sign firstly, or forgetting to multiply by 14641, which is the numerical coefficients. And again, carelessness of powers. For part C, with the substitution, this was the first 3 marks question in question 11. And to obtain the correct substitution in terms of U, the marks were allocated for that. Then they had to integrate successively to arrive at the correct primitive in terms of X. And then, of course, resubstitute, because it was an indefinite integration, into their final solution. And overall, this question was answered well. The error, or where there was loss of a mark, was when they did not replace the U with the X. There were some students who had X's as well as a DU. So special care needs to be taken in terms of substitution and keeping it either all to U's or all to the X's. In part D, which was our just a single mark question, was answered very well. Most students had the answer as 10 choose 5 times 8 choose 3, or they had the numerical value given as 14112. There were a few students who, instead of multiplied, added, and hence they lost their single mark. But again, answered very well. Part E, here, this was a rate of change question. And this question, sadly, if students just found their DV/DR and substituted, they would have arrived at the correct answer, but through incorrect methods. So obviously they would not get that mark. So many students could recall the formula of the sphere. They could find the derivative. So those students who answered it well went all the way through. Those who were not able to answer it went as far as finding the rate of change in terms of finding the derivative and substituting for the dr dt. There were some errors where students could not, there were few students who could not recall the volume of a sphere at all. Some could not derive it properly. And there were some students who could not use the chain rule correctly. So in terms of revision for this particular question, or this part of this question, I think students would need to practice the use of the chain rule and solving for the various parts of the chain rule correctly. Part F, this question, which was a definite integration, again using the inverse trig functions. Most students used the correct inverse trig function. Unfortunately, there were some who thought it was a log and tried to use the log function, which of course did not work. So here students were demonstrating their knowledge and content on inverse trig, mainly done well by students who knew what they were doing. They arrived at pi on 3 and they substituted the limits correctly. The issues here were incorrect use of the trig function. Some used cos, and as I said, some used the log. The next issue was incorrect use of, when substituting, they left it as 60 degrees rather than pi on 3. So that is something else that needs to be explained and discussed with students in terms of calculus to be using it in radian mode. Otherwise, this question was a relatively accessible 2-mark question. G. Now, this question was the question that was second 3-marker, and it posed many issues to a lot of students, but the issues were not the same. There were various difficulties in terms of this question. Those students who were able to answer this question did it pretty well. They factorized very easily, removed a compound common factor, solved for both expressions, got the sine squared x is a half and got it as plus and minus, so took into account that they were solving for a square and ended up with the correct solutions. The errors that arose from this question was that students needed to recognize that there was a highest common factor when they were factorizing the polynomial in terms of grouping. So instead of removing a sine squared, they removed a sine and then made errors thereafter. The other very, very common error was they had sine squared x is a half, but considered only the positive. So they only answered questions with sine x is 1 on root 2 rather than minus 1 on root 2 as well. And the other type of error that we found, students took across the 1 and then divided their left-hand side by x, by sine x, I beg your pardon, and thereby went completely incorrect. And finally, the third or the last error that was not as common but appeared was students wrote their answers in degrees and of course omitted some answers as well. So here I think the common errors or the issues that need to be looked at is correct factorization. When factorizing in terms of trig, and we had a square, we need to take a positive and a negative, and consider again your domain in terms of getting the correct number of solutions for the question. For H, where we were looking at the roots, Now, this question, quite a number of students omitted to realize that there was no power of 3 and there was no power of 2. So they attempted using alpha, beta, gamma, delta, but used alpha, beta, gamma, delta incorrectly with the sum and product of roots. The more able students got it out quite easily, so they obtained their 2 marks pretty easily, and they used the sum and product of formulas in terms of accessing the correct expressions. Students failed to actually find a common denominator with the appropriate numerator, which was quite disappointing because that was fairly simple algebra. So that was one of the issues. The second issue was getting B as 0 and C as 0, and hence made errors with their expressions. And the other issue was students who got the 3 on 6 actually wrote the answer was 2. So did not simplify the fraction correctly. So if they wrote 3 on 6, they got the mark. But if they did not write 3 on 6 and they just wrote that the expression 1 on alpha plus 1 on beta, 1 on gamma plus 1 on delta is 2, then they did not get their full 2 marks. So evaluating fractions correctly is a problem that needs to be addressed as well. Thank you.